Welcome to part 1 of notes 1.23. Remember, at any point you can pause this video if you need more time to write something down or think about something. You can even rewind and replay something that you need to see a second time. Also, there may be points at which I ask you to pause the video and work a problem in your notes. So please go ahead and do that because that will mean that you'll get the most out of what we're doing here. All right, we're going to begin today's notes with vocabulary. Vocabulary is so absolutely critical in geometry. There are many new words and many words that we use in a different way from what you're used to using them in regular language. So it's critical that you have a solid understanding of vocabulary. And to help convince you that vocabulary is important, we always give vocabulary quizzes, at least in the first few units that we do. So let's launch right into it. We're going to begin with a postulate. A postulate is a rule accepted without proof. Axiom basically means the same thing as postulate, and we very rarely use it in this class, but it's still good to know. On the other hand, a theorem is a rule that can be proved. And not only can you prove it, but you must prove it before you get to use it in a proof, but those come later. All right, let's talk about coordinates. Coordinates are the real numbers that correspond to a point. We can be talking about a coordinate on a number line or a coordinate on a coordinate plane, you know, that xy value that corresponds to a point. Then we have distance. Distance is the absolute value of the difference between two coordinates. And the reason why we say absolute value is because distance is always positive. So very important to know that, especially later on in class. All right, and let's talk about congruent segments. Congruent segments are line segments that have the same length. It means their measures are the same. And finally, midpoint, which is the point equidistant from 2 points on the same line. And hopefully you are familiar with both distance and midpoint from Algebra 1. All right, let's talk about some labeling differences. We are very picky about how we label our geometric figures. We're picky about everything because we're evil. No, because it's important. So when you see this over AB, it means the line AB. So A and B are points on the line, and it continues indefinitely in both directions. On the other hand, just one arrowhead means ray. And since the ray points towards B, we're talking about a ray with an endpoint at A, and then it continues on through B, so all the points on the same side of A as B. And then when there are no arrowheads on the little bar above AB, we're talking about a line segment. And a line segment can have a length. And the way we refer to that length is when there's nothing at all above AB. Then we're talking about the length of the segment, which is also the distance from A to B, and it is always a number. So you'll see something like this. Segment AB is congruent to segment DC, and that means line segments are congruent, whereas this AB equals means that we're talking about a distance, so AB equals 9. Okay, and we could also say something like AB equals DC, which means that I'm talking about the fact that their lengths are equal to each other. All right, and then we always mark our figures if we want to show congruency. So this little single hash mark right here means that these two segments are congruent to each other. And then if I want to show two different segments in the same figure are congruent, then I add a double hash mark. Same thing with angles. I can show that angles are congruent with this little hump thing. Shows me that angle 1 is congruent to angle 2. And then if I want to show that two different angles are congruent within the same kind of picture, then I can either add a hash mark to the little hump, or I can make it be like a double arc to show that these two angles are congruent to each other. Now we have our first postulate, first of many postulates you will encounter in this class, and it's called the Ruler Postulate, and simply says that the distance between 2 points on a number line is the absolute value of the difference of the coordinates between the two numbers, and that's what this equation shows here, right? AB, notice no bar over the top, so we're talking about the length of AB is equal to the absolute value of either point A minus point B, the coordinate of point A minus the coordinate of point B, or the other way around. Doesn't matter. Basically what it's saying is, if I know what A is and I know what B is, I can count how far apart they are on a number line, but we never say anything that straightforward in geometry. So here's an example. If I need to find the length of AB, if A is at negative 33 and B is at 15, so I can just take negative 33 and subtract 15, that's the absolute value, which gets me negative 48, and then the absolute value of a negative number is always positive, so it's 48. And you can see if I did it the other way around, so B minus A, 15 minus a minus 33, and minus a minus is a plus, that gets me a positive 48 absolute value, and absolute value is always positive, distance is always positive, so in both cases we get 48. So now we have our next postulate. It's called the segment addition postulate, and it simply states that if I've got point B between A and C, point B between A and C, then AB plus BC equals AC. Duh, right? Okay, so for example, point Y is between X and Z on XZ. So let's draw that. So I've got this line segment going on, and I've got X, and I've got Z, and then I've got Y, which is in between them. And then it tells me if XY is 35, and XZ, this whole thing, is 47, then YZ must be, oh goodness, let me see, what's 47 minus 35? I'm pretty sure it's 12. So YZ equals 12. All right. Now if we change it, and now we say that YZ is 15, so we're no longer dealing with this one, and the total distance is now 50, then XY must be, what plus 15 equals 50? Let's go with 35. All right, but obviously it's never going to be that easy, right? Because you know we wouldn't do that. So now let's talk about what happens when I have my same figure. So we've got X, we've got Y, and we've got Z, and we're dealing with algebraic expressions. So now XY is 2A plus 3, and YZ is 3A minus 1, and this whole distance, XZ, is 37. So hey, look, we already know one of the answers, 37. I would like you to pause the video and solve. Did you add these two together and set them equal to 37? Because that's what you should have done. Well, if you did that, then you would know that A equals 7. But remember, in geometry, whatever the variable is, unlike in algebra, is never our final answer. We're always going to use it to go figure out what something is. So we have to plug it back in and find out what XY is, and XY is 17, which means that YZ must be 20. If you didn't get that, please ask about it tomorrow in class. Remember your old friends, the coordinate plane from Algebra 1? We're going to use it a lot in geometry also. So we need to plot some points, and remember, just in case you've forgotten everything you ever knew, this is the x-axis, this is the y-axis. So when we've got points, that's x, that's y. So I'm going to plot point F. I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 5, and there goes F, and I'm going to label it because we always label our points. And then -1, +5, so this guy is up here, and that is G. And we've got H, which is 3, 3, so there's 3, that's H. And we've got J, which is 3, -2, so there's J. And it tells me to determine whether FG and HJ are congruent. So obviously I must have segment FG going on here, and I must have segment HJ going on here. And I need to find out whether they're congruent. Well, this tells me to find the length of them. So the last time I checked, to go from here to here, if I just count, that gets me 5 units. And to go from here to here, that gets me also 5 units. Therefore, FG equals HJ. Their lengths are the same. And also, segment FG is congruent to segment HJ, because if two lengths are equal, then the two segments themselves are congruent. And I know you think that seems very picky right now, but there will be a point to that later on. All right, I would like you to pause the video right now and to complete these two exercises. So you should have gotten that QS equals 61 and PQ equals 24 for the first one. And also, you should have found that WX equaled 6 and YZ equaled 5. And since 6 does not equal 5, then we would say no, they are not congruent. And your explanation would be because their lengths are different. Seems straightforward enough. Welcome to section 3. Okay, now I want you to pause. I know, we just started and I already want you to pause. Pause the video and I want you to find the coordinates of all of these points as well as what quadrant they are in. So go ahead and pause and make that happen right now. Okay, so A is located at 3, 4. B is located at -3, 5. C is located at -2, -5. D is located at 5, -3. E is located at -4, 0. And F is located at 0, 3. Quadrants, remember our quadrants are 1, 2, 3, and 4. Right? They go counterclockwise, make a big C. So A is located in quadrant 1, B is located in quadrant 2, C is located in quadrant 3, and D is located in quadrant 4. How very linear of us. E and F, those are trick questions. E is located on the x-axis, which is not in a quadrant, and F is located on the y-axis, also not in a quadrant. So now we come to some formulas. In geometry, anytime we show you a formula, we expect you to memorize it. Yay! And the first one is the distance formula, which you should already be familiar with from Algebra 1. And the distance formula simply is, if I have 2 points, x1, y1, and x2, y2, then I can find the distance between them by taking the square root of the difference of the x's squared plus the difference of the y's squared. And then if I want to find their midpoint, it's just the averages. So I add the x's together, divide by 2, and I add the y's together and divide by 2, and that gives me the ordered pair of the midpoint. So quick fact about the distance formula. If I have a right triangle on a coordinate plane, and this guy is located at x1, y1, and this guy up here is located at x2, y2, and I want to find the distance between them. Well, these x-coordinates are going to be the same, so this will be x2, and then these y-coordinates are going to be the same, so this would be x1. And since this is a right triangle, basically if I want to, I can find the length of this side, which we know length is the absolute value of the difference between the two coordinates. So since this is horizontal, I'm talking about the x-coordinates, so x2 minus x1. And these are the y-coordinates, so y2 minus y1. And then since we have a right triangle, our old friend, the Pythagorean Theorem, is going to make an appearance. And the Pythagorean Theorem says I take my two legs and I square them, and they are equal to the hypotenuse squared, which is what we're looking for, right? This is my distance right here. That's a D, by the way. Terrible penmanship. All right, so if I take a squared, which is going to be x2 minus x1 squared, and I add b squared, which will be y2 minus y1 squared, it'll be equal to d squared. And then if I want to find out what d is, I just take the square root of that. And since this is an equation, if I want to do it to one side, I got to do it to both sides. And oh, look, that's where the distance formula comes from. It's simply the Pythagorean theorem. So if you can turn your points into a right triangle, you could just use the Pythagorean theorem. And that's what I always do. All right, so we have John. He is a diligent paper boy, delivering his papers rapidly. And he has to deliver to Parker, Elm, and Maple. And we need to find the distance between Parker and Elm. Well, Parker here is located at 4, 1. and elm is located at 0, 4. So if I were to use the distance formula, then I would say that that distance is the square root of, let's just for fun make this x1, y1, and this x2, y2. It does not matter which point you label x1 and which point you label x2 as long as the x1 and y1 are together. All right, so I'm going to take 0 and subtract 4, and I'm going to square it, and I'm going to add that to, let me see, 4 minus 1, and I'm going to square that. All right, so I've got the square root of negative 4 squared, which is positive 16, because when I square any negative number, it becomes positive, no matter what your calculator tells you. And 4 minus 1 is 3, and 3 squared is 9, so 16 plus 9, which means I have the square root of 25, and the square root of 25 is 5. So that's how far apart Parker and Elm are. You pause this video and you find the distance between Maple and Parker. So you should have gotten that the distance between them is the square root of 85. And we're going to put units after that. I forgot to put units after that. If that could be simplified, you should, if you could reduce that radical, but you can't, because I'm fairly sure it's 5 times 17, and neither one of those two can be reduced any further. So we're just going to keep it in simplest radical form, because that's what we do in geometry. Unless you're told otherwise, you keep it in simplest radical form. All right, let's talk about midpoint. So now I want to find the midpoint of Parker to Elm. No, I'm sorry, I'm Maple to Parker. And Maple was located at -3, -5. So to find the midpoint, I simply add the x's. So I'm going to add 4 plus a -3 and divide by 2. And I'm going to add the y's, which will be 1 plus a -5 and divide that by 2. All right, so that gets me 1/2. And this gets me, what, -4 divided by 2, so -2. So 1/2, -2. We're going to also leave our fractions in fraction form, not decimal form, unless you are told otherwise. All right, you pause the video and you find me the midpoint of EM. So you should have found that the midpoint of EM was -3/2 and -1/2. Now we don't have a nice graph. We're just given 2 points, and we need to find AB, which implies distance, and the midpoint. So pause the video and find me the length of AB and the midpoint of AB, and then you might as well go on and find the length of CD and the midpoint of CD. So get to it. All right, so you should have found that when you apply the distance formula, you get the square root of 45, but that can be reduced. So it's the square root of 9 times the square root of 5, and the square root of 9 is 3, so your final answer should have been 3 radical 5 units. And then the midpoint of AB is 1/2, 1. All right, similarly, when you find the distance to CD, you should get the square root of 18, but that's the square root of 9 times the square root of 2, and the square root of 9 is 3, so you should have gotten 3 radical 2 units. And then the midpoint of CD is -1/2, 3/2. If you didn't get that, please make sure you ask about it in class tomorrow. In this, we're given one endpoint and a midpoint, and we're asked to find the coordinates of the other endpoint. So you got a couple options here. You can use the midpoint formula. So I know that -7 is the midpoint, and so it's going to be equal to x1, which is -2, plus x2 divided by 2. And I know that the y value 6 of the midpoint is going to be equal to y14 plus y2 divided by 2. And so I can solve each of those 4. So 2 times -7 is -14, so I get -14 equals -2 plus x2, add 2 to both sides, and I get x2 equals -12. All right, and then if I do the y value the same, 2 times 6 is 12, so 12 equals 4 plus y2. And then I subtract 4 from both sides, so I get 8 equals y2. However, I have an alternative to the purely formula method. If you like it and it makes sense to you, fabulous. But if it's not so fun for you and you'd rather do it much easier, here's how I do it. Make 2 number lines. This is the patented Uken number line method. All right, so I have a number line for my x values and I have a number line for my y values. And I know that, let me see, I've got an endpoint at -2 and a midpoint at -7. So a -2 is one endpoint, and then -7 is my other midpoint. And so I always draw a dot here to show it's my midpoint, which means my other endpoint needs to be on the other side of that. So you need to be careful how you draw it, right? Because -2 is going to be the right of -7, and then -7 will be the right of the other endpoint. So this is what I'm looking for my other endpoint. Well, these guys are 5 apart. So if I move 5 in this direction, so there's 5 here, 5 here, that gets me to -12, which gets me my one endpoint. And then we do the same thing for y. So I've got 4 for my endpoint and then 6 for my midpoint. So 4 will be over here this time. 6 is my midpoint. There's 2 here, so I'm going to go 2 here, and I'm going to get 8, which means I get the point -12, 8 in both cases. So whichever one you prefer is perfectly fine. All right, and then we need to find AB. So again, it's talking distance. So we're going to use the distance formula. And let's see, so we've got the distance between the square root of difference of the x's. So I'm going to take -12 and I'm going to subtract -2 and I'm going to square that, plus the difference of the y's. So 8 minus 4, and I'm going to square that. All right, so a -12 minus a -2, I think I forgot a second set of parentheses in here, that gets me -10 squared plus 4 squared. So I get 100 plus 16, so 116. Now 116 is not one of those numbers that you automatically think, ooh, I should reduce this, or I know exactly how to reduce it, so you need to check. So we're going to use our old friend, the factor tree. All right, so 2 and 58 and 2 and 29, that's not divisible, but here I have a pair of 2's, which means that my final answer is 2 radical 29 units. All right, last slide. You guys happy? I'm happy. I'm told that K is the midpoint of JL. Well, a midpoint divides my segment into 2 congruent segments, which means that if these guys are congruent, their lengths are equal to each other. So 8 minus 3x equals 2x plus 5. So we're going to solve, add 3x both sides, we get 5x, subtract 5, we get 3, divide by 5, x equals 3/5. But we all know that that's not the answer because the asks us to find the length of KL, which means I need to go ahead and plug this back in. So 2 times 3/5 plus 5, so I get 6/5 plus 5. Now, if I'm going to add these guys, they should probably have a common denominator. Yay, fractions, which means I'm going to need to make a denominator of 5. So I'm going to multiply by 5 over 5. That's 5 over 1. So I get 6/5 plus 25/5, and that equals 31/5. And we are going to leave our answer exactly like that. Absolutely positively, no decimals, and no mixed numbers. Got it? All right, that concludes tonight's lesson. So if you have any questions over any of the sections that we've covered, please make sure to have them ready when you come in to class tomorrow. Thanks.